sir. Shall we start?
Sir, we will wait for 3 more minutes, sir. By 7 we will start, sir.
Yeah. Okay,
Okay.
sir.
Yes, sir.
Respected Principal Sir, Professor J.V.R. Ramindra, HOD Sir, Professor Asif, coordinators of IEEE PES chapter, Vardhaman College of Engineering, Hyderabad, Professor N. Karyoppa, and Dr. Praveen. Good evening, everyone. I am Dr. Rajat, Assistant Professor of BCE. I would like to mention my deep sense of appreciation for our expert speaker, Dr. Vasist Bist, for accepting our invitation to deliver the expert talk on career opportunities in technical core. Dr. Bist has completed his PhD in electrical engineering with specialization in power electronics, electrical machines in 2014 from Indian Institute of Technology, Delhi. Prior to this, he has completed diploma and BE in instrumentation and control engineering from Sant Longowal Institute of Engineering and Technology, Slide, Punjab in 2007 and 2010 respectively. He was the silver and gold medalist in his diploma and BE respectively. He has worked for Fuse Electric as Assistant General Manager in R&D Group, working primarily on renewable energy and high power electronic converters. And also he worked for Texas Instruments as a system engineer and got involved in definition of motor driver power ICs. So currently he's working with Allegro Microsystem, Avantgarde Solutions Private Limited as a system engineering manager. He has co-authored 2 patents, more than 60 publications in leading journals and conferences, and numerous industrial notes. So out of 60 publications, I think around 20 journals are from IEEE transactions and IET journals. He has been conferred with many prestigious awards, including Central Bank of India Award, IEEE IAS Annual Meeting Award, POSOCO Power System Award, that is PPSA, FITT Award for Best Industry Relevant PhD from IIT Delhi, Amit Garg Memorial Research Award for High Impact Publication in Quality Journal, and NAM PET Research Award by the Ministry of Communications and Information Technology, Government of India. He has also been conferred with the prestigious Indian National Science Academy INSA Young Scientist Award in 2017, which is considered as highest recognition of promise, creativity, and excellence in a young scientist. His areas of interest include brushless DC motor drives, trapezoidal and sinusoidal, brushed DC motors, stepper motors, motor driver power ICs, power factor correction converters, high power converters, and power quality. So now I would like to request Dr. Bist to start the session, sir.
Hey, hello. Thank you, Rajat. Hey, hello. Good evening, everyone. So Rajat, thank you for inviting me to this talk. And I'll just, without any wasting any time, I'll just start my session. Let me share my screen first. Guys, can you see my screen?
Yes, sir. It is visible, sir.
Yes, sir.
Okay. Topic of today's talk is not very technical, frankly speaking, and I would really like to explore some of the opportunities in technical, right, and the similar problem we also faced during our BTech time, or even in our master's duration, that we are studying this and that and lot of subjects, and really what to focus and what will be really gaining out of that, and whether those type of things will be really useful in industries or not. And really that's the challenge which in a electrical core industry. So I'm definitely referring to electrical, electronics and instrumentation, and that type of challenge, what to really study for that. So I would like to really focus on few of the points or few of the topics today, which really help you to understand that where are really the core jobs are, and what type of expertise, what type of softwares, what type of skills like our industries will be looking, and what are the really growth opportunities in those type of industries. So I want to keep this session a very interactive session. If any students or anyone having any queries, just stop in me in between. And I don't have a very big presentation to present, but I want to spend more time in some technical discussions with the students and faculties. So my topic of presentation today is like my career perspectives in technical core, and agenda for this is we will talk a little bit about industries, what type of end equipment. I will try to cover really a lot of industries and all focusing on various type of equipments. And again, I'm referring to industries related to electrical, electronics, and instrumentations here. I'll give you an example of automotive industry and how everything and how each and every part, how are there a lot of jobs available at different domains, particularly, and different type of skill sets is again required for those type of jobs. We will talk a little bit about like many students will be having interest in their hardware or a firmware, some like coding, some like to work on hardware PCBs, or even simulation softwares like magnetic thermals. So we'll talk a little bit about that, and if time permits, I'll talk a little bit about the semiconductor industry also, and overall skill development. How would I really see that? How you should focus starting from first year? Any questions till now? Okay. Yeah, please stop me in between if you have really any queries. So if I really talk about industry as a whole, so there are like mainly classified into 5 or 6 categories. So if I see as an automotive industry, again a very big industry, India is really focused on a lot of automotives, whether you consider four-wheeler or two-wheelers. So if you see two-wheeler is like a biggest market in the world for India, and even four-wheelers, lot of end equipment manufacturers, on lot of OEMs, lot of tier ones, lot of these companies are there. So to name a few, you can see like we do have Maruti, we do have Tata, we do have Suzuki, we do have these are like the OEMs, the original equipment and equipment manufacturers. And then we are going towards a tier one. So these are the companies which provide a lot of solution to these companies. So which are like Hella, BEHR is there, and then Denso is there, then Continental is there. A lot of these companies, they all do have, even Bosch is there. They all do have their R&D centers, their development centers in India, and almost each of these industries is having at least 1,000 people working for them. So that is a sort of an automotive industry. So there are a lot of opportunities there when you say about a ADAS system, your body electronics and lighting, hybrid electric vehicle, and infotainment cluster. I'll just focus on one of this, that how does that look? Then second one, a very big sector is the industrial one. Industrial one, you can see everything here, your aerospace, your appliances, your automation, your factory automation, building automation, your grid infrastructure, or your general electric, and everything will come under your grid infrastructure. There are industrial transport. The transports which are not covered into the automotive are covered into the industrial one. Then there are a lot of lighting industry. You can see a lot of fancy lighting, LEDs, CFL, everything is coming up. So a lot of lighting and the power converters development around this one is there. A lot of medical, motor drives itself is a very huge industry. And then power delivery, your audio and videos, and a lot of others. The third sectors, personal electrics. So after personal electronics, after your COVID period, this sector eventually has boosted up a lot, and you can see a requirement of PCs, notebook, TV, your tablet, your wearables, and your data storage eventually. So this sector eventually has picked up a very big spike, and lot of semiconductor or even the lot of electronic component makers are really targeting this sector also after the post-COVID period. Then there are communication equipments, and then there are enterprise system. So let me give a little bit brief overview about this section, which is your hybrid electric and powertrain system. So you can see that this is a very just a one-liner, and just give me a minute. Yeah, this is just a one-liner, but you can see here inside this, your hybrid electric and powertrain, you can see a lot of applications of this, your hybrid electric vehicle or your powertrain sensors. Sensors itself is like very huge industry to work on. Like the company which I work, Allegro Microsystem, they are like the leader in the automotive sensors. So you can see a lot of sensors, and there will be a lot of skill set requirements for the development of these sensors or the applications around these sensors. And moreover, there are like engine management, there's like a transmission, power steering. Electric power steering itself is a very big area, and there are relatively, you can, if you just look onto LinkedIn and try to find this electric power steering, you will find jobs specific for this type of requirement. So my point here is that so I was just referring to one of the section of the automotive, and here you can see that even in that there are a lot of applications or lot of places where people are required, right? So a lot of people will be doing that work, will be designing power steering, or will be designing a turbochargers, will be designing pumps and everything, will be working on the DC-DC chargers, regulators. A lot of things are there, and uh, and relatively these type of opportunities, India has seen a relatively very high spike in these type of opportunities. Lot of companies want to invest here because of the talent available, and obviously the market of India is also very big. So you can see almost all the OEMs or even all the tier ones, they do have their R&D, or they do want to plan their R&D in India in coming years, and already working a lot in the automotive domain. Uh, any questions till now? Okay, let's go ahead. So uh, what I'm planning to do, I'm planning to show you some of the jobs which I have taken from LinkedIn, and again from some different companies, and I'll try to show you how the skill sets, what are the skill sets they are really looking from these job point of view. So let's say, for example, this job is from Intel Corporation, right? And this is like a senior hardware engineer. So what are they really looking? So the education experience, obviously, you're like in hardware design, but you don't worry on this, like they are asking 8 years experience or 5-year plus experience. Somewhere everyone will be starting, right? And you can see here that the amount of technical knowledge is they have just written the high-speed interface or board design that includes a lot of details around that. And even for like DC-DC converters, control loop, simulation tools, voltage drop analysis, and power integrity. So that is the amount of technical knowledge they are looking, and they have just summarized into 2 lines. But again, that requires a lot of background to really talk about on these points. Then definitely you will be needing tools, you will be understanding tools when you are working on gaining knowledge in these. Then you can see for these type of jobs, the leadership, your execution, your communication, your problem solving attitude, everything matters so much, right? So that is one sort of the hardware job where they will be looking people who can work on their board designs, who can work on their validations plan, who can actually work on in their labs and work with the customers, define their solutions. That is the type of the hardware job. And then there are definitely firmware jobs. So firmware jobs, this is again one of a very big company, Microchip Technology. And this is again very related to motor drive. Now you can see here, this job is just asking a BLDC motor control. And if you have already worked on the BLDC, so all of these things, you might have already worked on that. And even the second point also, it is a brushless DC, permanent magnet synchronous motor, again, the type of BLDC, and AC synchronous motor, and some sort of experience if you have anything on that. So you can see these type of jobs related to control algorithms, these were not very famous before, but as the amount of uh, microcontrollers, the high power DSPs are increasing, and everything has to be controlled with the DSPs. So these types of jobs are increasing day by day. This is just one example of a motor control. Then there will be similar type of jobs for the power factor correction, similar type of jobs for the for any of your UPS or any grid connected system. Everything you will be working, the industry of these sort will be looking for these. And rest all you see, if you are good at C, you just have to extend your skill to the embedded C, and this embedded C with some knowledge of motors and definitely a very fun knowledge of motors can be extended into a whole together firmware job. And believe me, they do write like a experience requirement for these type of jobs, but they do consider freshers for these type of jobs also. I know people who have some experience around those and are already sitting in these positions in these companies. So any questions? Yeah. Okay, so yeah, again describing this job is that you need a motor knowledge, some domain specific knowledge, then you will be having some sort of software experience. So MATLAB is something I will talk about in a little bit more detail. Then some sort of subject-wise knowledge. You will be already working. You will be already studying these subjects, right? Analog and digital circuit design, motor control. You will be studying your high power. You will be studying your, and if you are studying these and if you are working on these, you will be definitely having these type of experience. And definitely you can see like these type of jobs, they do want you to go to US or go to Japan, go to Korea to solve customer needs, to align with the team and everything. And believe me, these type of jobs, if you really go into this domain, these are all the BTech or MTech related subjects. If you have already studied everything in this, nobody can stop you getting these type of jobs. Okay, so any questions till now? Yeah, I think, yeah, if you have any question, please don't hesitate. And this is some sort of interactive session I would like to keep. And if you have really even the silly questions, you can ask. And we just want to have a one-to-one discussion with the students. Okay. Yeah, can you guys hear me, Rajat?
Yes, sir.
Okay, okay, yeah, it's very quiet here. Okay, so like some sort of power electronics has really emerged a lot in past 1 or 2 decades, and now you can see everything has to be, the power has to be really controlled, and you can see that this job is again from Tata Elxsi. Tata Elxsi is the EV generation group for Tata. And if you really see the requirement for this job is that you should know something about the switching based control strategies. You should have some experience onto the tuning of the power electronic devices, and you should have experience in DC-DC converters and onboard charger. So these type of things, a student really used to work in MTech or a BTech level, in the final year projects level. If they really work even for 1 year, understanding just one sort of converter and trying to understand what are really challenges on that. So in 1 year, these type of jobs can be easily cracked, because see, even if you can see, they have not written anything on the experience requirement, so they don't really care whether whether you are a fresher, whether you are a 5 years. They will just pay you accordingly. But you should have some experience or some good level grasp on these type of requirements. So you should definitely do some projects on DC-DC converters. You should start with like what are the components. You should design their control, do some simulations in MATLAB, PSCAD, LT-Spice. A lot of softwares are there, very easy, and a lot of free softwares are there. You should start designing their the PCB in Altium, and even some free softwares are also there. you should try learning about some new experience of thermals. Then once PCB is done, try soldering your components, try the testing, do some comparison. So if you are really trying, if you are really planning in such a way and try to divide your time to do such the kind of things, and these are really, really very simple things to do, and you'll be definitely gaining a lot of experience to get into these type of roles. Then definitely you can do in power electronics. Power electronics is a very huge, right? You have power factor correction controllers, motor controllers, battery chargers, onboard chargers. Power electronics is again extended into the automotive, industrial, everywhere, right? So power electronics will be everywhere, and you will find jobs related to this also everywhere. So if you really love working with hardware, working with power, so that is the domain you should definitely work on. The other type of requirement is like motor drive. So motors, again, wherever the things are moving, it has to be motors, whether it's a traction motor in a car. And just to give you an example, so car maybe 20-30 years back were having like 5 to 10 motors, and now if you are talking about the cars nowadays, a high-end car can have around 150 motors also. So you can see the motor requirement in just an automotive has increased from 10 to 15 to almost 150, almost 10 times in like last 20-30 years. So now you can see the background requirement for these type of motors. There will be all type of motors there, like your brushless DC, brush DC motors, your stepper motors will be there. So these motors, if you really learn about these motors, like the control algorithms, how these motor works, how to control them, lot of fun things to do around. And this is again the job which I have been working before, the system engineer in Texas Instruments. And you can see you have to work on the field oriented control and trap control. So again, these things will be studied in your BTech level or in MTech level, or you can even do some projects around that. And for doing that, MATLAB or PSIM is the really basic thing to start. A lot of examples are there, lot of free codes are there, lot of supports are there online, and it's very easy software to start. You should definitely start MATLAB, and MATLAB will give you all the exposure to how all your systems are working. And then you can see your requirement on the motor control applications and converting use case to algorithm software requirements. And again, a lot of these. Again, you can see like there is really no requirement of some fresher. It doesn't say that you need a fresher, you need to have some experience, because these type of roles really, if you are good, the companies will take it. And these type of roles really are very specific roles. People are very less in India, and they do pay you a good salaries also. Yeah. Any questions?
Sir,
Yep.
I have a question, but it is very long question. Will you able to answer it?
Sure, definitely.
So we know that according to the recent numbers posted by the automobile companies,
Huh?
there is a huge shortage of semiconductors and chips.
Yes.
Why India is lagging behind to enter in this sector for manufacturing the semiconductors?
Mm-hmm.
Is there any entry barrier for this sector, or we have no technology for the manufacturing of these chips?
Okay. Hey, sorry, I can't understand. So someone is also saying, is he asking on the similar question? Okay, so I will answer you on this point. So what happened? So a lot of semiconductor industries in the world are fabless. So they don't have their own fabrications. And then there are few of the big companies, the semiconductor manufacturing fabrication companies, like you can see a global foundries, then your TSMC in Taiwan, then your USMC are there. So there are few of the global foundries which do manufacture wafers for a lot of these semiconductor industries, right? Only few semiconductor industries like big giants like Texas Instruments or ST Microsystems, those are the big companies who can invest in the fabrication, the fab. And if you have heard the news that Tata has also recently tried to invest in fab, there are no good level fabs in India till now. So these fabrication facilities, these are very costly. So when I'm saying costly, at least you need a $2 to $3 billion to put just one fab. So this type of investment uh, really require a lot of funds, and not a lot of semiconductor makers can afford that type of funds. So what they do, uh, they give their they design their solution and give that to the, say for example, global foundries, and they give them the wafer back. So wafer is where your ICs die are getting generated. So so before COVID period, everything was going fine, everything allotment was good. But as soon as COVID period, so as soon as the COVID started, your automotive demand has suddenly dropped down. So no semiconductor manufacturers are asking for the wafers from these manufacturers. So what they have done, they have allotted those type of they have allotted their deliveries from automotive sector to the electronic sector or the personal electronics, whether you say data centers, laptops, and everything, the consumer grade. And so once they have allotted this, the automotive share reduces drastically. And as soon as the as soon as the lockdown reopens, the automotive demands again spike suddenly. But their allotment was not there. They cannot now leave their personal business there, right? The consumer grade business there. So their allotment has spiked up recently. So it's like a supply demand gap. So supply has increased suddenly, but the demand has increased suddenly, but supply is not there. So that's why you can see a lot of news today that semiconductor makers, semiconductor manufacturers cannot able to provide. But if you see, there are definitely good companies who have uh, planned their requirement way before. They are still having, you still see a lot of cars are going, and a lot of cars are manufacturing, and they are still working. And this issue is expected to resolve in like 1.5 year. Does that answer your question?
Yes, sir, but
Yep.
uh, in computers or in any other electronic devices, we use chipsets which are fabricated with 3 to 5 nanometers each.
Yep.
Mm. In automobiles, how much range na chips are used?
Okay. Okay. Yeah, that's a very good question. So even in automotive, there are, so it doesn't so these nanometers is nothing to has to do with the segment of the industry. This has to really do with the what voltage levels they are working. So for example, if you see like a 3 nanometer or 5 nanometer, these are generally the high-end processors or high-end controllers, right? Like for Qualcomm or so Intel or Samsung. So these are the processors which will be working on, say, for 3.3 volt or even 1.8 volt. And even now they are trying to reduce at 1.2 volt. So these are the controllers category. So controllers will also be used in the automotive. You still need controllers uh, to run your motors. You still need algorithms to run. You still need algorithms to run your ADAS for your LiDAR system. You still need controllers there. So all those controllers will be still developed into the 3 nanometer or 5 nanometer, and your power components. So if you are seeing like 100 volt, like for say, I'll just give you an example, like for 50 to 100 volt type, They were at 180 nanometer, and now they have shifted from 180 nanometer to 130 nanometer. So as technology enhances, so even for the high voltage or high power, the technologies, the nanometers are also reducing. But it will be a mix of all in all the space. Yeah, is that okay?
Yes, sir. I heard that China invested more than $5 billion in manufacturing these chips,
Yep.
but they are used to get only 50 nanometer range chips.
Yes.
Is there any right technology for reducing this nanometer range?
Yes, yes,
Only I
definitely.
heard that TSMC is the only company which is manufacturing 3 nanometer range chips.
Okay, yeah, you are definitely right, because see, when you go in the lower nanometers, the technology cost doesn't increase linearly. It increases in the 2x or 5x or 10x fold, right? Say for example, if Tata has seen that he has to make components which are really of the power category or really of the high voltage category, and he need to invest 5 billion. And if he really have to make components which is like a 3 nanometer, he might have to invest 500 billion, right? So it is again a stake which Tata has taken, that at what place and at what market he really want to enter, right? And again, you also have to see the investment as well as returns, right? Because those markets are really very saturated. You can see Samsung, you can see Qualcomm, they are already leap ahead, and nobody really want to go there unless they are very big. So for becoming big, first you have to start with the power space, and then you really have to go into the digital space. Right? The answer for this is still more of a how much you want to invest and what you can make and how much profit you can get. It is more of a business business opportunities for them.
Yes, sir. Tata Elxsi, KPIT and L&T Technologies are working for software of case technology vehicles.
Mhm.
Is there any companies working for hardware chipsets manufacturing companies in India?
So when you
For
say, yeah, so there are like a lot of so what I'm was saying that there in automotive was divided into two categories, right? One is the OEM. OEM is the original equipment manufacturers. Those are like the Tata, Mahindra, Maruti Suzuki, and one is the tier one. Those are the service, those are the providers for these OEM. So if you have heard the name Varroc, or if you have heard the name Hella, if you had heard the name Bosch, so these are the places where they will be developing the whole level board, whole level solution for these companies. And to answer your question, yes, there are a lot of companies doing that in India. Okay. Okay, shall we go ahead?
Thank you, sir.
Yeah. Yeah, so from from motor drives to definitely there are a lot of opportunities in microcontrollers. It is again a very what I say, it's a very broad area, and microcontroller programming, people who really like doing working coding, and they can start with microcontroller programming, move to high-end DSPs. Then there are low-end Arduinos also. Then there are high-end ARM Cortex cores also. And then if they are really interested into going into some mix of analog and digital, they can start doing the FPGA programming. So generally what I see that a lot of these institutes, or a lot of even lot of institutes have these type of facilities, but I don't see a lot of students really using that. Like I have seen like FPGA boards a long back, but nobody was using in IIT Delhi at that time. So lot of these things will be available, and you just have to explore. And once you started going deep into these techniques or these microcontrollers, once you try to learn all those techniques, really nobody can stop you. So, like for example, this is one of the electronic company, and see, you just have what he is looking. You just have some electronic design experience, and you should have some experience onto the microcontrollers, FPGA or embedded firmware. So if you have already done some level of embedded firmware, they will try to ask you very basic questions, and if you can only able to answer if you have worked on that. If you think that only by studying or something I can able to crack those interviews, that will be very difficult. But if you have worked on one of these controllers, you can able to answer those questions, because you will be facing those problems, and that person who will be taking that interview will be asking those problems only, and that only you can answer once you have already burned your hand in those programming. So again, this is like an example of a microcontrollers. Now, some people really who don't like hardwares, but they are very much interested in softwares, want to learn. So this is again one of the ZF group. This is one of very big group. I think this is a Europe or a Swiss group, and these are like a tier 1 again for automotive. And you can see this guy is only asking if you have experience in MATLAB and Simulink. Like MATLAB and Simulink, I started when I was in BTech second year. I started using MATLAB and Simulink at that time, and you can see now MATLAB and Simulink has really become a part of our life. Whatever I need to model, I just open MATLAB, just put some components, and it's just a matter of 15-20 minutes for me to simulate anything now. But if you have to start it now, and you can see these type of jobs. This is from ZF Group. This is from NXP Semiconductor, one of again very big semiconductor company in India, and they are just really looking for these softwares, right? MATLAB, Simulink, or even Cadence, your Spice. If you like, this is one of the free software, LT Spice. If you really want to go into IC level type of modeling, this is like a MATLAB. If you really want to understand on a system level type of modeling, so try using these type of models, these type of simulator softwares, and you will definitely see a lot of job opportunities around that. The one thing is definitely PCB design there. So some people think that PCB design is like a diploma type of jobs or something, but it is not. So eventually we also do a lot of PCB design, because PCB design is not just layouting this, it is actually layouting your high speed, high power. You have to consider your crimpage, clearance, thermals, your high speed, EMI, noises, everything you have to consider. And those things you can only able to consider when you understand the system. So just putting those components and layouting is not the PCB design, and it is more of understanding the whole system. And once it is done, and you really have to think in lot of issues while designing a system, while designing a PCB. And you can definitely see this is Johnson Control. Johnson Control is a US based heavy vehicle industry or heavy vehicle automotive industry. It's again in Pune, and you can see they are asking for requirement on the PCB layout softwares, right? And PCB design process, minimization of errors, and everybody is looking for Altium designers and BOM estimation. So everything around PCB, there will be definitely a lot of jobs openings around that also. So again, I'm trying to give you some exposure or some options, what really you can do and where your interest lies. You should try exploring those things. One of the really very key interesting areas is coming up in magnetics and thermal design. So till now, not a lot of magnetics or not a lot of thermal design was happening in India, but now since your requirement of EV has come up, people really want to go cheap. They don't want to import from China or for say any other place. So they don't want to develop their own motors, own transformers, everything related to motors here also. So you can see people really work in the lot of magnetics, how flux, how field is going through, and then they really move into computational fluid dynamics, and all level of modeling are there, but everyone has to start from the zero, and this is again a thermal level modeling, that your PCB or your board, how temperature you have to, how temperature gradients you have to spread and everything. What are the techniques on that? This is again one of the job. If you heard this company Honeywell, a very well-known company, and you can see they are just looking for these softwares, right? You need a ANSYS, Maxwell, MotorCAD, ProSim, PSpice, MathCAD. Again, this is like very a very standard softwares for modeling of electromagnetic systems. And you can, if you really like working on these, you should try your hands on these one. Okay, any questions till now? Okay, I think before going to that, I just have one slide. As you were asking about semiconductor, and not a lot of people really know about semiconductor, I just want to give you one brief idea. In India itself, there are a lot of semiconductor industries. If you're starting with your TI, ST, ROHM, NXP, Freescale, a lot of companies in Bangalore, in Pune, in Delhi, NCR region, in Hyderabad. There are a lot of even Qualcomm, Intel, everything is on the semiconductor. So I just want to share you some IC development process, and what you should take from there is what type of roles and how the whole IC development process is happening. So what happens? So it obviously everything starts with the product definition. You will take input from customers. You will see what type of products are required in the market. So that is the type of role which I have been doing. And then it goes to the design portion of it. So for electronics engineer, if you are really into analog circuits or digital circuits, you start working on the cadence, environment, and you will learn how to design your buffer, how to design your high-speed circuitry, how to design your charge pump, how to design your drivers. So start doing that. So this happens in the cadence environment. It goes to an analog and digital design engineer. So they design the circuit, and then it goes to a verification engineer. So if you see, you will see a lot of analog mixed signal verification engineer or digital verification engineer. These are very hot roles in India, and people are really for a good verification engineer, the companies are really willing to pay a lot for getting these type of engineers, because it is a very important domain for industry, for IC industry. Because once the IC is made, once the simulation or the IC is designed, you have to verify whether it's working perfectly or not. So it also requires the knowledge of the IC design as well as the knowledge of how it will be tested. So once this is done, then comes the layout. You will be layouting your IC, and then there are layout engineers requirement for that. So like you were asking, the KPIT and those guys, they do a lot of layout work also. Some industry really send this layout work to third party, and a lot of industries who want to protect their IPs will work that in-house. So once it is there, this goes to fabrication. So this is the wafer which I was talking about. So these TSMC and these global foundries really provide you these wafers. So their contract will be the semiconductor company will give them the design, and they will give them back the wafer. So this wafer costing and everything, the issue with the automotive industry today is with its wafer actually. So once the wafer is reached, you will have to cut these wafers into small dies, and then you have to fit those die into your packaging. So a lot of job requirement will come around the reliability, around a lot of qualifications. The packaging industry itself is a very huge industry, because every wafer has to be packaged. And then these package will come back to the lab. You have to test it. You have to ensure that it is working fine. There are a lot of validation setups will be there. There will be a lot of automation test setups. Automation test setup means These setups will be like where the testing site will be there, will be deployed in those. These are also very expensive setups. This is like one of the setup this guy is working on that. And there are a lot of opportunities even in India nowadays. Like a lot of companies have their test center also in India. They do a lot of test level development here. And once it is done, your test setup will go to a testing site, and then it is the IC final testing before it is released to market. So this is the overall market flow. And then again, there are a lot of other functions also which I'm not describing. A lot of customer support, lot of even the third level design. And but you can see at all levels, India, there are a lot of opportunities, really not on the fabrication side for now, at least, but at least on the other remaining 7 categories, there are a lot of opportunities in India. And just they will be really looking for some engineers having good background, good grasp on technical, and you will definitely get there. So any questions on the development process? Okay. I just have one last slide, which I feel this is again one of my thought process, and this is how I have also not did a lot of things in that, but this is what I feel that once you enter into first year, you should get exposure to MATLAB, and eventually your C type of subjects are there. You should start working on to the C. So in that case, the benefit is that you will be start getting familiar with MATLAB or PSpice, and once you start getting investment in first year, with 4 years you will really become expert on these softwares. So choose whatever you want to work on, but start doing work on MATLAB PSpice and try to see, like for example, analog circuits, your transistors, your network theories. Try to model them with MATLAB. It will just hardly take 5 minutes once you are good at that. And try to see that whatever questions you are solving, whatever are they matching or not. Try with that. Then second year, your control and those subjects started. Then MATLAB really becomes very handy. You will learn about pole, zeros, compensator. Control is eventually a very important part of your all power electronics, or even for electronics also. Then microprocessor, microcontroller, start learning on those. Then once you are in these 2 years, you are good at MATLAB, you are good at programming, and then third year you start taking the advanced courses, right, where power electronics, motors, gate drivers. Then you will be trying to put these systems in MATLAB or trying to implement these systems in microprocessor, microcontrollers. In the spare time, you can start learning the Altium software. This is again a very simple software, but main idea behind is that you should start learning the PCB methodology. What does that mean? And then you will be definitely having more command on MATLAB and programming, because you will be using those things to implement all of these. And then fourth year, once you are taking the overall project, you start with your simulations, you start with your PCB design, then assembly, microcontroller programming, testing, and then these things are really manageable in 8-9 months. And once you have everything, you can start put some publications or reports around that. So that is what I feel the BTech 4 year, or even you can compress it to for per semester for the MTech students. But this is what I feel that you should try to learn, but definitely, if not everything, but definitely try to grasp some of the things which you like. Say, for example, if you like MATLAB, or if you are good at C, try to develop that skills in that domain. And definitely once the time comes, you will definitely get the advantage, as you are seeing in these type of jobs. Okay, yeah, I think that's all for my presentation today. And we do have like 10 minutes. If you have any questions, this is my email ID, and I'm on LinkedIn. So you can definitely write me there. I'll try to reply as soon as possible. But if you have any questions now, you can ask.
Good evening, sir.
Hey, hi, good evening.
Yeah, this is Dr.
Hey, hi. Hi, doctor.
Sir, any necessary for the energy conservation sector?
Sir, your voice is breaking too much. I couldn't understand anything.
Okay. Yes, sir. Any sector, a skill set is necessary for the energy conservation related to the energy conservation.
Sir, I'm really very sorry. I couldn't able to hear anything. Your voice is breaking too much. Can you write that question or? Am I audible to you? Can you hear my voice clearly?
Yes, sir. Yes, sir. So you're audible.
Okay, okay, because I cannot hear your voice.
Hello, sir.
Yes, now it's better.
Yeah, yes, sir. I want to know about the skill set necessary about the energy conservation sector, sir.
Energy conservation sectors. So,
Yeah.
so when you are saying energy conservation sectors, are you also referring to like the companies like General Electric or the companies who are making batteries or something like that?
Yeah, yes.
Okay, so yes, sir. So right now, what we are really looking, the industry is really looking onto the chargers, right? So charging industries and lot of things are really going around chargers, right? And charger is something which is not, which looks very easy, but when you start going into details, it start becoming very complicated. So when I see onboard chargers, now you can see the next challenge coming up will be implanting those chargers. You will be needing a charge. So for example, if you are having an electric car in future, you will be needing one charger at home, and you will be needing a charging stations, which will be like the range of hundreds of kilowatts type, because they have to charge few cars at a time. And so if I see the skill set requirement, you definitely need to work on to the DC-DC converters, and definitely on to the high frequency side, high frequency control side of that. The second most important thing right now is the magnetic design. So magnetic design is something which not a lot of people are good at. And if you start picking up that in the early days, it becomes very handy, because magnetic design is not everyone's piece of cake. And then once magnetic design is there, your controller is done, then definitely power electronics, your DC-DCs will start coming up. Then the problem related to DC-DCs will also start coming up. And then there are uh, then once that is there, you have to really have to tune the system also. So that's where control will start coming up. And since everything is connected to grid, there are the grid level stability problems also, which like a lot of big companies like GE, or even your what is that company name? So all those who are making really like the working onto the solar portion of it. So there are a lot of groups really involving those challenge, the power system stability, transients, and again things related to the MPPT, the solar related query, the systems, MPPT, and all the algorithms and the chargers related to that. So yes, there are just to shorten that, there are a lot of again, when I say power electronics, I cannot say that you should not learn control or you should not learn DSP, because power electronics itself is a whole package. You really have to work everything together at the end of the day.
Yes, sir. Yes, sir. Thank you. Thank you very much, sir.
Yeah. Yes, any more question?
Hello, sir.
Hi, hello.
Why India is lagging behind case technology?
What do you mean by case technology?
Connected autonomous shared electric.
Connected autonomous?
assisted electric.
Sorry, I'm not very much aware. Is that related to like the autonomous vehicles, or what is that?
It's related to electric vehicles only, sir.
You are saying
Which
about the
is
case, CASE?
yes, sir. CASE.
Okay. I'm hearing this word, sorry, first time. And maybe I might be aware. Case, you are saying in automotive, right? Is this you are referring to? Case automotive trends? So you are referring to the autonomous thing, right?
Yes, sir.
Okay, so I'll tell you in a very short thing, right? So right now, see, India is a country where I don't I don't think that we are really very much ahead in technology than others, right? The requirement for Indian automotive is really more from a like a mass point of view, right? Because India, I think autonomous is very far behind, because you see the structures and everything in India is very far behind, right? Like lot of companies, we do provide lot of support to the autonomous vehicles, but again, those are mostly related to the drivers. But when you see as a autonomous system as a whole, developing that in India, it doesn't make sense, because the market itself, it's not even emerged in lot of powerful countries, right? Not even in US that technology is fully adapted, right? So I think before that coming to India, it will take at least a decade or more. I don't think that is coming before that in India, because we really have to fight first challenge of electric vehicle, right? So that is the first challenge before us. So once that challenge is overcome, then only we can think of automotive. And this challenge itself is starting from the EV development. So right now you can see, right, the Tata Nexon has released his EV. So that priced, it's very high, right? 17, 18 lakhs or somewhere in that range. And you have to get this cost down first, so that everyone really can able to afford EVs. Then you have to build the infrastructure for EVs. Then really, since petrol price is going up day by day, that EV trend start pulling in. So these all infrastructure and everything on the EV development will be first, and then only India can think of autonomous. I don't think that is coming at least for next 10 years or so. Does that answer your question?
Thank you, sir.
Okay, yeah, I think if there are, yeah.
So participate.
What is the future scope of NFT?
You have any more questions?
I think someone is asking something before.
NFT.
You are saying about NXP?
Yes, sir.
So are you saying about, sorry, I didn't understand your question.
What future scope of NFT?
Are you asking about NFT or the company NXP?
NFT.
Hey, sorry, that's not my domain. I'm very sorry. I don't have any idea on that. So better I should not comment on that, because that really comes under very core onto the personal electronics and more of a software related type of domain. So I don't have any experience on that. I'm really very sorry. Yeah. Okay, guys. If there are not any more questions, so then I think we can wind up the session.
Yeah, hello, sir. I think all the queries are.
Yes.
So thank you, Dr. Biz, for enlightening
Yes, yes.
knowledge and providing us the deep insights of this industry sector.
Yeah.
So it was really a wonderful session. And now I'd like to request Dr. Muthu Perumal to give vote of thanks. Sir, Dr. Perumal.
Yes, thank you, sir. On behalf of Vardhaman College of Engineering, the IEEE PES Society, I'm taking the great pleasure to say the word of thanks for this wonderful event. First of all, my sincere gratitude to Dr. Vashit Bist, System Engineer Manager, Electro Microsystem, to accept our invitations and shared his valuable guidance with us. Thank you very much, sir. You are shared the many important skill set that is necessary for our electrical engineers. Really, our PG students and UG students is benefited about that. You handle all the sector-wise skill set also. Include the last slide also, the UG students, how they develop the skill set in the year-wise. It's a really appreciate thing, sir. We'll implement the same thing to our campus also. For giving this wonderful opportunity, our head of the department and the organizing committees, IEEE society members and the students members and the participants, faculty members, is all of you for the great inspiration for doing this type of continuous motivation for this knowledge sharing. And once again, I'm saying my sincere thanks for one and all for a great successful event of this thing. Thank you, one and all.
Yeah. Thank you, sir. Thank you very much for this session.
Thank you, sir. Thank you very much.
Thank you.